Welcome back. We're going to continue talking about that angle of inclination. What did we say was the angle of inclination? It was the angle between the x-axis and the line, always in an anti-clockwise direction. Now, we're going to jump into the next question. The next question says, determine the angle of inclination. They want us to find that angle of this line. Now, how did I calculate the angle of inclination? I used the formula. Tan theta is equal to m. So what do I need? For this question, I need the gradient, all right? But before I can calculate what the gradient is, I need to have my graph, my straight line graph, in standard form. If it's not in standard form, then I can't decide what the gradient is. And so my standard form is always going to be y equals mx plus c. What do I need to do? All I need to do is I need to get y alone on one side. Currently, the x is on the same side as the y, and so I'm going to take it to the other side. I'm going to add x on both sides, and I'm going to get x plus 6. Then the y is still not alone. There's a 2 with it, and so I'm going to divide both sides by 2, and I'm going to get y is equal to a half x plus 3. Wonderful. Now that I have y alone, I can decide the number that I'm multiplying x by, that half, is my gradient. And this is great, because once I have my gradient, I can go and calculate the angle of inclination. And so let's do that. Tan theta is equal to a half. Tan theta is equal to my gradient. And how did we decide we were going to do this? Well, we were going to shift tan. We were going to do that on our calculator, shift tan of a half. And so let's go to our calculator. I'm going to go shift tan of 1 over 2, close my brackets, and what am I going to get? I'm going to get 26,565, so I'm going to round up there, 26,57. I'm going to get theta is equal to 26,57 degrees. The angle between my line and the x-axis in an anti-clockwise direction is 26,57. Wonderful. Let's turn to our next question. Our next question says, determine the angle of inclination of the line that passes through the points -4 and 1, 2, and 5. Again, all I'm ever going to do when we're doing analytical geometry is I'm always going to use a formula. So turn to the formula sheet. You've got 4 formulas. You've got the distance formula, you've got the midpoint formula, you've got the gradient formula, and you've got the angle of inclination formula, tan theta equals m. Which one am I going to use here? Well, they want me to determine the angle of inclination, and so I'm going to use this formula, tan theta equals m. But to use that formula, I need the gradient. Exactly like we did in the previous question, I need the gradient. And so here, how am I going to calculate the gradient? Well, I'm going to use the gradient formula. And so my gradient formula is y2 minus y1 over x2 minus x1. What is that? Well, let's go do that. I'm going to go y minus y, 5 minus 1. Again, this is where we need to be careful. I'm not subtracting 1. I'm subtracting -1. And so it's so easy to just write 5 minus 1. It's not. It's going to end up being 5 plus 1. And so whenever you substitute a negative value, always make sure that you do it in brackets. At the bottom, I'm going to get 2 minus 4. This ends up being 6 over 6, which is equal to a gradient of 1. Wonderful. Now that I have my gradient, I can sub it in, and I can work backwards to calculate theta. Now, when we've spoken about shift tan, actually what that is that's the inverse of the function, and in maths we call that arctan. But regardless, on our calculators, we're just going to go shift tan. I'm going to go shift tan of 1, and so let me go to my calculator here. I'm going to go shift tan of 1. And what do I get? I get 45. And so I know that my angle is 45 degrees. And that makes all sense because the gradient of 1 means it's going up as much as it's going across, which would create, let's draw that, if it's going up 2 and it's going across 2, what sort of triangle have I created there? A right angle triangle, which is isosceles, which is going to be 45 and 45. Wonderful. Okay, let's move to the next question. The next question says, determine the angle theta, this angle there, all right, in the sketch below between the two lines, y equals a half x plus 3 and y equals negative x plus 4. Now, this is as complicated as these questions can get with the angle of inclination. This is where we need to be really switched on, all right? How are we going to do this? How am I going to solve for that angle? Well, what if I did this? What if I calculated the angle of inclination of the line going down? This line going down, I calculated that angle there, because I can do that. And I work out the angle of the inclination of the line going up, right? I can do that. We've discussed that. We know how to do that now. If I have the angle alpha and beta, the two angles of inclination, what am I left with? Have I not got that? All right. Can't I solve for this sketch geometrically? Does everybody see here that if this, let's give these random values, if this was 30 and this was 120, it would be quite easy to calculate what theta is. I can go and work out that this angle is 60 using angles on straight line, all right? And then I can just go and, because I know that all the angles in a triangle add up to 180, I can go say theta is equal to 180 minus 30 minus 60. And I can work out what theta is. Alternatively, and this is what I would prefer you guys to do, but either way it's going to get you to the answer, is does everybody see that alpha is the exterior angle of this triangle? And so what do I know? That beta plus theta is equal to alpha, or I put in two pluses there, let me take that out. And so I can say that theta is equal to alpha minus beta. All right? We've spoken a lot, but the point of this is that if they want an angle between two lines, what am I going to do? I'm going to find the angle of inclination of the one line, angle of inclination of the other line, and then I'm going to use geometry, normal geometry, to go find the angle that they want me to find. All right, so let's actually do this question now. All right, I've shifted the sketch to the top here so that I've got more space to work. I'm going to work out alpha, I'm going to work out beta, and then with geometry, I'm going to work out what theta is. Excellent. So let's start with alpha. Whenever I'm working out the angle of inclination, what am I going to do? I'm going to use this formula, tan alpha, tan of the angle is equal to the gradient. Now, the gradient of this line is minus 1. And so I'm going to get tan theta equals minus 1. All right. I'm going to put that into my calculator. All right. And I'm going to get theta equals, and let's go do that in our calculator. Oh, sorry. There. I'm going to go shift tan of minus 1. And I get an answer of minus 45. Now, we discussed this earlier in the lesson. I can't get an angle, a negative angle. And so what are we always going to do when we get a negative angle is all we're going to do is we're going to add 180. And so I'm going to take that minus 45. I'm going to add 180. And I'm going to get an angle of 135. I know that this angle alpha is equal to 135. Excellent. I'm halfway there. And if I can calculate beta, I can hopefully calculate what theta is. Excellent. So let's look at beta. I know that beta is the angle of inclination of my line going up. And so I'm going to go and I'm going to write tan beta is equal to m. This is the formula from the formula sheet for the angle of inclination. I know the gradient of the line going up, well, is going to be the number that I'm multiplying x by, which in this case is a half. And so I'm going to go and say tan beta is equal to a half. Now I need to calculate what beta is, and so I'm going to go and use shift tan on my calculator. So let me go to my calculator. If I go shift tan of 1/2, what do I get? I get 26,57. Remember, we rounded up for that when we did this last time. So I'm going to get 26,57. Excellent. So now I know that this angle is 26,57. And what did we decide? Is that if I know, and let me write my two angles in there, 135 and 26,57. This is 135. This is 26,57. All right. Because theta is inside the triangle and beta is inside the triangle, I can say the two interior angles sum to the exterior angle of my triangle. And that's sort of exactly what we're going to do here. Is we've simplified this already, but theta is equal to 135 minus 26,57. I'm going to do that on my calculator to make sure that I get this right. I'm going to get 135 minus 26,57. And if I do that, I'm going to press SD there because I want a decimal answer. I'm going to get 108,43. So what do I know is that that angle there, theta, or what did we say it was? 108,43 is 108,43 in the center. So whenever we have an angle between two lines, always what I'm going to do is work out the angle of inclination of the one line, work out the angle of inclination of the other line, and then use geometry to solve for the angle that they want me to solve. Excellent. It's been wonderful. Thank you for spending this time with me. I will see you guys next time. Good luck with your maths, and goodbye.